So this particular problem talks about friction forces, especially static friction forces, and then how to see the correct direction of the friction forces and using Newton's third law. Okay, so let's look at the problem. A block X rests on top of another block Y. Both the blocks are on frictionless horizontal table, right? So there's no friction here. There's no friction here. There's a friction between the two blocks. However, there's a friction between the two blocks. Okay, so there's a friction between the two blocks. Horizontal force is applied to block Y in case number A, and horizontal force F is applied to block X in the case number B. In each case, draw the horizontal forces acting on each block. So we are not worried about the vertical forces, but only horizontal. So let's start with A. Okay. First thing first, on this block, which is Y, the force which is acting horizontally is first force F, which is very clearly seen. Now let's draw for X. Okay. Because the two blocks move together, which means there has to be some force which is acting on X, which is taking it towards the right, which means the force of static friction here is going to act towards right on the block number X. Okay, this is a friction force which is acting on X towards right. By the virtue of Newton's third law, we'll get a reverse force on Y acting towards left, right? Because this is the force pair for the Newton's third law, right? So these two forces, equal and opposite, will act. So on the block number Y, two forces F minus F, and on the block X, the force F will act, and both of them are static friction force. Another way of looking at this is that the static friction force ensures that there is no relative acceleration, right? So when we try to pull the Y away, basically it will try to accelerate towards F. Hence, the static friction force will try to ensure that there is no acceleration. So acting the friction force on X towards F, ensuring that X goes along with the Y. And with the Newton's third law, we can reverse the direction on the Y like that. Now let's look at option B. This time, the force of friction is going to be in the other direction, right? But we'll see the force F on X basically acts here. Okay. And now we draw Y here. The Y is also going along with the X. So the force of friction now on Y is going to act in this direction. And by the Newton's third law, the force of friction on X is going to act in the other direction. Can you see the difference? Right? In the first case, the force of friction on Y was acting towards left. Now it is acting towards right. So it really depends upon where the force is getting applied and how the friction force behaves. The key thing is that the static friction force will ensure that static friction force will ensure that there is no relative acceleration. Okay, so the direction of the static friction force will behave accordingly. When we try to accelerate this block towards right, automatically it will ensure that Y also goes in this direction. So static friction force on Y is going to be towards right. And by the Newton's third law, then we can devise that is going to be equal and opposite on X, right? So on the X, it is going to be the other way around.